So let's look at a couple more example problems where we have factorization of polynomials with substitution. And remember that we essentially have two different cases we're going to look at. When we have a perfect square, so some number plus some other number, or they could be variable expressions, when you add these together and then square them, you get this formula here, u squared plus 2ub plus b squared. And we also have the case of difference of squares, which we looked at in the introduction video, where you have u squared minus b squared. You have two numbers squared and you're subtracting, you're finding their difference. And that factors into the first one plus the second one, ignoring the squares, multiplied by the first one minus the second one. So for this particular problem, they tell us that we can factor the expression as u plus v squared. And we need to figure out what u and v would be and then actually write it in its factored form. So this is the case of a perfect square here. So let's first start by just rewriting the problem to get a little bit more familiar with it. So we have x minus 5 squared plus 2 times y to the third multiplied by x minus 5 plus y to the sixth. So what you can notice is that we have some term squared, and then in this middle term here, we have that same term but raised to the first power. And then at the end, notice we have this y to the sixth, which in some sense is a term raised to the second power. That's really y to the third squared. And then we have that same term but raised to the first power. So remember, y to the sixth is really just y cubed squared. So we just need to recognize this pattern here, and we also have the 2 in that middle term, so that we can rewrite this as our perfect square. And so determining what u and v are from our formula, so let me just rewrite the formula so that we can compare it. We have u squared plus 2vu or uv, it doesn't matter. In this case, they've written it as v times u. And then we have plus v squared. So maybe it's a little bit clearer now how to match it up to the pattern. But essentially, this is u squared, this is v, this is u, and the y to the sixth is our v squared. So in other words, u is x minus 5, and v is y to the third. So these are a little bit harder to recognize than a difference of squares, but they do show up often enough that it's worth looking for the pattern to see if they can be factored in a nicer way. And we could just match it up to the formula now, since we know that a perfect square factors as u plus v squared. So just plugging in everything to our formula here, this polynomial here will factor as u plus v, and then we're going to square it. So we'll have this x minus 5 for u, and then we're going to add v to that, and v is y to the third. And once we've written this out, we're going to square the entire expression. So this is what we think is the answer as our factored form of this, but we can also check this. We can re-multiply this out to make sure we end up with what we started with. So let's actually do that, and we'll need to make some space for that since this will require a fair amount of work. So we have this perfect square here, and to actually multiply this out, we need to rewrite the expression twice. So we have x minus 5 plus y to the third, and we multiply that by x minus 5 plus y to the third. And I'm going to leave this x minus 5 grouped together so that it's easier to see that this is equal to what we started with here. So multiplying this out, we're just going to use distribution. We're going to multiply x minus 5 into both of these. So x minus 5 times x minus 5 we'll just rewrite as x minus 5 squared. And then we have x minus 5 times y to the third. So I'll write that as y to the third multiplied by x minus 5. And then we distribute the y to the third to both of those. So we get y to the third times x minus 5. So we end up with that same expression, the same term as the one before it. And then y to the third times y to the third we'll just write as y to the sixth. Now notice we do have like terms. These are the same thing, so we can add them together. Or in other words, there's going to be two of them. So we end up with x minus 5 squared plus 2 times y to the third times x minus 5. And then we get plus y to the sixth. So you can see that we do get back what we started with. It's this same starting expression. So that means we can feel confident that this is the correct factorization of the given polynomial.